Hey, what is up guys? It's Kerry here, back with another video, and today I want to show you the 5 most commonly made mistakes in C programming and also show you how you can avoid them so you don't make these mistakes and save you a lot of debugging time when you are writing your C code. Okay, so let's get started. Mistake number 1, the sizeof mistake. So the sizeof is the operator that we use all the time in C programming to get the size of a variable or a structure. Okay, and you have to be really careful when you use sizeof on a array data type or a pointer data type, because you have to remember the sizeof will return you the number of bytes that particular variable occupies in memory. Okay, so for example, when you're working with array of 20 and you want to use sizeof, it will actually return you the number of bytes it occupies in memory, which is 1 times 20. So in this case, this is okay because char is 1 byte long and we have 20 of them, so this will loop 20 times, no problem. But this one is not okay because it's working with an integer array, which each integer will occupy 4 bytes in memory, and you have 20 of them, so it will return you 80. So if you loop like this, it will loop 80 times and you will go out of bound and crash your program. So the correct way to do this is not to use sizeof here, but instead you just simply put 20 so it does not go out of bound. Okay. And lastly, if you use sizeof on a pointer, you will always get 8 bytes because that's how much this pointer occupies in memory to store a memory address, right? So what you really want with this string copy, you really want is the length of this string, which is 5 characters long. So in here you should not use sizeof, but instead you should use the string function from standard C library to compute the number of characters pointed by this character pointer, okay, which is 5, and that will work. Okay. Mistake number 2, the compare pointer mistake. So we know that in C programming we can compare 2 variables using the double equal operator, right? But we normally use that with regular variables like my number 1 and number 2. But when you're working with pointers like this, which points to another variable, and you want to compare this pointer, you cannot just compare like this because it will actually compare the address of this pointer that points to, and because they are 2 different variables, they occupy 2 different segments of your memory, and therefore they are different in terms of memory address. So compare 2 pointers like this will always result in false, even though they point to the same value. Okay, so you do not compare like this. So instead you need to dereference these pointers using the asterisk sign in front of your pointer name. So you will actually take the value pointed by this pointer, which is 200, and carry on with the comparison, and it will return you true in this case, which is the correct behavior. All right. Mistake number 3, forgetting about terminating null characters in a string. Okay, so when we are learning C programming, and especially with streams, we are always taught that you have to use a terminating null characters at the end to indicate the end of the stream. Otherwise, the C program will interpret that incorrectly. So for example, I have a character array of 20 characters, and I'm gonna put all 20 characters with some value. So there's no room for terminating null characters. And then I'm gonna go ahead and use that string variable in the printf or in some other operations, and most likely those will result in either a crash or it will overwrite some other memory space in the stack, causing some other component to fail. So that is something that we don't want because that will take a long time to debug. Okay, so when you are working with string, remember you have to +1 here for a terminating null characters, and you have to make sure the last character in the string is indeed a 0 or a terminating null characters, and you can easily do that with a memset function before you actually use these string variables. So what I'm gonna do here, I'm just gonna set everything to 0 using the memset function, and of course I'm using the sizeof to indicate the entire memory space that you will occupy. And then I will go ahead and do a string copy, which occupy the first 20 characters, and the last one is indeed a null characters. So that way it will ensure all my string interpretation will be correct afterward. Mistake number 4, structure containing a pointer mistake. Okay, so when you're working with a structure, and especially with a pointer to a structure, you have to be really careful when that structure contains additional pointer reference to another structures or another variables. Okay, so for example, I have a structure A right here that contains a pointer reference struct B that points to this structure called the struct B. Okay, and in this function example, I'm using the struct A as a pointer as well. So before I use that, I will go ahead and allocate memory using the sizeof operator, which will return me the size that you will occupy in memory. Alright, and of course, after you successfully allocate memory, you can start using the structure, giving it some ID, for example. But as soon as you start using the pointer reference inside the structure A, and you want to reference to this ID as well, and want to make that to some other value, this line will crash your program because struct B inside struct A has not been allocated memory, even though you have already done so with the struct A, the whole thing. But that does not include the memory address of this pointer. Alright, so it is now pointing to nothing. So in order for this line not to crash, you have to allocate memory for B as well using the same malloc function, but with a different name. It's instead of A, you want to call this B. Okay, here and there. When the allocation succeeds, and then you can go ahead and use that variable inside the structure A and then assign it some value, and you will not crash. Mistake number 5, the free pointer mistake. Okay, so when you're working with a pointer reference, and you sometimes will want to use the arithmetic operations like this plus equal to change this pointer's reference to point to different locations. Okay, so for example, I am using this buffer pointer, and which I have allocated 8 bytes to that. I want to encode these 2 integers inside this 8 bytes long character or pointer. Okay, so what I'm gonna do that, how I'm gonna do that is I'm gonna first allocate memory, so buffer PTR, so it will now point to the beginning of this 8 byte of memory that I have just allocated. And then starting from the beginning, I'm gonna do a main copy the value of my integer number 1 here, and I want to copy 4 bytes because the integer occupies 4 bytes in memory. Okay, so after I've done this copy, I'm gonna move this pointer reference 4 bytes ahead. So from that 4 bytes ahead, I'm gonna do another copy, copying my integer number 2, and of course with size of int, which is 4 bytes. And there I have the whole 8 byte of integer copied to this pointer, this buffer pointer. And then when I finish with this buffer pointer, I'm gonna be using the free to clear up the memory allocated so that your program does not leak memory, right? And when you free a buffer pointer like this line will also crash your program because the system does not know where the buffer pointer is. It doesn't know what this means. It doesn't know how much memory to free because it does not recognize this buffer pointer. Why does it not recognize? That is because we have already changed the reference of that buffer pointer when we carry on with this line here. In order to complete our encoding, we've shifted the pointer, and therefore we cannot free like that. Okay, it has to point to the beginning of the memory that you allocated. Okay, so the way I would do this, I will either declare another pointer called temp, and I'm gonna initialize to null first, and then as soon as I finish allocation, I will make that equals to buffer pointer. And then I will go ahead and use buffer pointer and shift the reference and in order to build my buffer, right? And then at the end, when I am done with this buffer, I will instead free temp pointer because that has not changed. It's always pointing to the beginning of the buffer pointer when I have first allocated memory. So in this case, this will not crash. Alright, so that is the 5 most commonly made mistakes according to my experience, and I hope that by sharing with you today, you can also try to avoid the same mistakes and save you a lot of time in your debugging, okay? So if you like this video and if you have a question for me, you can feel free to leave a comment below. And if you're interested in learning more about C programming, you can check the link in the description where I have the fully comprehensive beginner-friendly course on C programming available for you to learn if you are interested. So again, check the link in the description, and I will see you next time.